Hi, how is it going? Welcome to Code with Z. Today's question is LeetCode number 15, threesome. In this question, we're basically given an array of numbers and we gotta return all of the triplets that if we add them together, they're gonna be equal to 0. Now I'll explain everything and visualize the whole algorithm in the coming slides, but just for the sake of reading the question itself, let's take a look at the examples. As you can see, we're given an array of numbers and we gotta find out the triplets that their sum is equal to 0. As you can see, we have -1 plus -1, that's -2, plus 2, that's gonna be 0. So the sum of this triplet here is 0. Same thing here, -1 plus 0 plus 1 is gonna be 0. So inside of here, we gotta find the triplets that if we add them together, they're gonna be equal to 0, but we should not have any duplicates. Alright, let's solve this together, and don't worry, I'll visualize the whole algorithm, literally all of it. This slideshow took me ages to build, but I hope it provides you with value, and I won't finish this video until I make sure you fully understand how to solve this problem once and for all. So these are the numbers that we were given, and they're all inside of an array, and we gotta return an array that contains all of the triplets, right? So for doing that, we gotta have a result variable that we gotta return at the end. So let's do that. As you can see, our result variable is gonna be initialized to an empty array. We're gonna return this at the end, and now I'll explain how our algorithm would work, and then I'll visualize the whole algorithm for all of the numbers that we have here. So first, let's start the explanation. So in our algorithm, we're gonna have a loop. This is representing a loop. This is gonna be a for loop, and because it's a for loop, we're gonna have a variable, for example, called I, and this I is just gonna keep on incrementing on each round. So this is the variable of our loop, and inside of our loop, we're gonna have a variable called J, and we're gonna initialize it to I plus 1. So if I is 0, J is gonna be 1 because 0 plus 1 is gonna be 1. And then we're gonna have another variable called K, and K is gonna be equal to numbers.length minus 1. So basically the length of this numbers array here minus 1, and that's going to be equaling to the last index of our array, which is going to be 5. So K is going to be equal to 5. Then inside of our loop, we're going to have another loop, and don't worry, again, I'll visualize everything step by step so I make sure you fully understand it. This is just to explain the algorithm. Inside of our second loop, we're going to have a sum variable, and this sum variable is going to be equal to numbers of I plus numbers of J plus numbers of K. This is saying inside of our nums array, get the number with the index of I. So for example, if I is 0, we're going to get the number with the index of 0, and that's going to be -1. And then this one is saying get the number with the index of J, and if J is 1, we're going to bring this number here. And this one is saying get the number with the index of K, and if K is 5, we're gonna bring this number here. And then we're gonna add these three together and we're gonna get a sum. Because again, remember, our goal here is to find all of the triplets or the combinations between these three that are gonna be equal to 0. So we need to have a sum so we can see if it's gonna be equal to 0 or not. Then after that, we're gonna check if our sum is actually equal to 0. If it is equal to 0, we're gonna add our combination to our result variable here that was defined here. And our combination is gonna be numbers of I and numbers of J and numbers of K. This is our combination. If it was not equal to 0 and it was greater than 0, we wanna decrement K. So whatever our K variable is here, if our sum variable was greater than 0, we're gonna decrement K, and else we're gonna increment J. This way we're gonna find all the triplets that are gonna be equal to 0. And then at the end, we're gonna return our result. Now to make this algorithm work, we need to actually sort our numbers here, like so. This is literally the same array. We're just sorting it from the smallest number to the biggest number here. And this is it. Now let's start the visualization process. So in the beginning, our I is gonna be equal to 0, and the number with the index of 0 is gonna be -4. And our J is gonna be equal to I plus 1, and that's gonna make J be equal to 1. And the number with the index of 1 is gonna be this -1 here. And then our K variable is equal to the numbers.length -1, meaning the last index of our array, and that's gonna be 5, because numbers.length -1 is gonna be 5. Then we're gonna enter our second loop, and we're gonna calculate our sum. So we're bringing these numbers down, and we're gonna calculate it and see if it's gonna be equal to 0 or not. So -4 plus -1 plus 2 is equal to -3. So as you can see, it's not equal to 0. So if sum is equal to 0, it's not. So we're going to ignore this line here, and we're not going to enter this if statement. And then we're going to say, is sum greater than 0? Well, not. So we're also going to ignore this if statement, and we're going to fall inside this else, and we're going to increment J. So let's do that. J is equal to 1, and it should be equal to 2 now. And as you can see, because we incremented J, Now j is pointing to this number with the index of 2, which is this -1 here, and we're still inside of our second loop, and we're gonna keep on looping. So our new sum is gonna be equal to -4 plus -1 plus 2, and that's gonna be equal to -3 again. And as you can see, it's not equal to 0. Our sum is -3, so it's not equal to 0. Our sum is not greater than 0, so we're gonna increment j once more, like so. So our j is gonna be 3, and it's currently pointing to this number here. We're gonna calculate our sum again. Our sum is gonna be equal to -4 plus 0, because our j is pointing to this number here, plus 2, and that's gonna be equal to -2. And again, our sum is not equal to 0. Our sum is not greater than 0, so we're gonna increment j one more time, like so. So now j is equal to 4, and the number with the index of 4 is this number here, and we're gonna calculate our sum. So -4 plus 1 plus 2 is equal to -1. Again, our sum is not equal to 0, and our sum is not greater than 0, so we're gonna increment j once more. But if we do increment j, that's gonna make j be equal to 5, meaning j would be equal to k, and we don't want that because here we say we wanna keep on looping as long as j is smaller than k. So this is the condition for our second loop here. So just know that we're gonna keep on looping as long as j is smaller than k. That's it. And if this was not the case, meaning if j was not smaller than k, we're gonna break out of our second loop, like so. So we broke out of our second loop, and then our I got incremented because our I is the variable for our first loop. And this happened because we just finished one iteration of our first loop. So when this inner loop was finished, we got out of it, and there's no other lines of code below it. So we finished one iteration of our first loop, and we're gonna start the second iteration, and that's why I is gonna be equal to 1, because I just got incremented. J is redefined again, so j is equal to I plus 1, so that's gonna make j be equal to 2, and k is still gonna be equal to 5. And these three are pointing to these three numbers here, so -1, -1, and 2. And now we're gonna enter our second loop again, and we're gonna calculate our sum. So our sum is gonna be equal to -1, like so, and this -1 came from here, then plus another -1, like so, plus 2, and this is actually equal to 0, as you can see. So we're gonna say if sum is equal to 0, as you can see, sum is actually equal to 0, we're gonna add our combination to our result, like so. -1, -1, and 2. -1, -1, and 2. So we just added our combination to our result. But what should we do now? We're currently inside this if statement, and we just added our combination to our result, but we still need to decrement k and increment j to keep on looping and to look for other combinations. Because think about it, we just added the combination that was equal to 0 to our result. But this doesn't mean this is the only combination. We might have other ones, and we gotta check with the different values of I, j, and k. And we're actually stuck inside of this if statement because j and k are not being updated. We said we were gonna update k if sum was greater than 0, and we also update j in our else statement, but we also have to update them if our sum is equal to 0 because we wanna look for other answers. So let's do that. Let's add some space here, and then let's do that. We're gonna say j++ to increment j, and then k minus to decrement k. And this will make sure that we keep looking for other solutions. So let's do that. We just added our combination to our result, then we're gonna increment j and decrement k, like so. So j is now equal to 3, and k is equal to 4. Now they're pointing to these numbers here. So let's calculate our sum again. Sum is gonna be equal to -1 plus 0 plus 1. As you can see, -1 plus 0 plus 1, and that's also equal to 0. So we're gonna say if sum is equal to 0, add the combination to our result. Let's do that, like so, -1, -1, 0, 0, 1, 1. And then we want to increment j, then after that decrement k. But if we increment j is gonna be equal to k, and we're gonna break out of our loop because j is not gonna be smaller than k. So let's break out of our loop, and we're gonna enter the third iteration of our bigger loop. This time our I is gonna be equal to 2, and j is gonna be equal to I plus 1, and that's gonna make j be equal to 3, and then k is gonna be equal to 5 like before. But if we take a look at this, we could see that I is equal to its value in the previous round. And if we enter this second loop again, we're gonna end up with the same results because I didn't change. In the previous round, I was equal to -1, and now it's equal to -1 again. And if we enter our second loop, we're gonna have a duplicate because it's gonna give us the same answer, and we're gonna add the same answer to our result again. So how can we overcome this problem? Well, as you can see, everything would be awesome if this number was not equal to this number here. The problem occurred because I is equal to its previous value. Well, we can simply say if the number that I is currently pointing to is equal to the previous number that I used to point to, we want to continue. And what this continue does is that it's going to skip everything below it and it's going to enter the next iteration of our loop. So it's basically like saying skip this round. So let's do that. Now I is equal to 3 and j is equal to I plus 1. So j is going to be equal to 4 and k is going to be equal to 5, meaning our I is pointing to this number here, our j is pointing to this number here, and our k is pointing to this number here. So we're going to enter our second loop and we're going to calculate our sum. So 0 plus 1 plus 2, that's going to be 3. Is sum equal to 0? It's not. So is sum greater than 0? It is. So let's decrement k. But if we decrement k, k is going to be equal to 4. And that's going to make k be equal to j, which results to breaking the condition of our second loop. And we're going to break out of our loop. Now, the last thing that I should tell you is that the condition for our for loop here is that we're going to loop as long as I is smaller than numbers.length minus 2, meaning we're gonna keep on looping as long as I is smaller than the index of this number. Why? Because we have two other pointers that are gonna take care of these two numbers, because k was always pointing to this number here and j is always one number bigger than I. So these two numbers are actually taken care of and we've actually checked them in the previous rounds. So there's no need to actually keep on looping and make I be equal to this number, because if we do that, j and k are gonna be equal to each other and we can't even enter the second loop. Because if I is equal to this number here, j is gonna be equal to the number that's next to I, so it's gonna be pointing to this number here, and k is pointing to the last number in our array, that's gonna be also this number. So we can't even enter the second loop, and we don't need to because we've already checked all of the combinations, and this is our result, so we're gonna return it. Now let's code this in the simplest way possible. Alright, so first let's define our result variable, and that's gonna be equal to an empty array, and then we gotta sort our numbers just like we saw in the slides. So numbers is gonna be equal to numbers dot sort a and b, and then this is gonna be a minus b. And this is just how we sort arrays in JavaScript. So this is gonna sort our array of numbers. Then we're gonna define our for loop. So for let I be equal to 0, and we wanna keep on looping as long as I is smaller than nums.length minus 2, just like we saw in the slides, and then I plus plus. Then we're gonna get inside of our for loop, and inside of here, we're gonna say let j be equal to I plus 1, and let k be equal to nums.length minus 1, just like we saw in the slides. And then to make sure that we don't add any duplicates to our result, we're gonna say if nums of I is equal to nums of I minus 1, meaning if the current number that I is pointing to is equal to the previous number that I used to point to, we want to continue. And then below it, we're going to define our for loop, and we're going to say while j is smaller than k, do the following. And we're going to say let sum be equal to numbers of I plus numbers of j plus numbers of k. And then we're going to say if sum is equal to 0, do the following. So we want to add our combination to our result. So we're going to say result dot push, because our result is an array, as you can see. So we're going to push the triplet array inside of it. So we're going to say nums of I, nums of j, and then nums of k. So we're pushing our combination or our triplet inside of our array here. Then we're gonna say j plus plus and k minus minus. Let's zoom out a little bit. Else if sum is greater than 0, we wanna decrement k, and else we wanna increment j. And at the end, we're gonna return our result. There's one more thing that we need to do that's related to skipping duplicates, and we gotta do it here. So when we say if sum is equal to 0 and we actually add our triplet to our result, we gotta make sure when we increment j and decrement k, the new values of these two are not gonna be equal to their previous values, because if we have that, we're gonna have a duplicate again. We're taking care of the duplicates for I here, but we don't actually take care of the duplicates for k and j anywhere. So to do that, we're gonna say while the numbers of j is equal to numbers of j plus 1, increment j. This is for j, and then for k, we're gonna say while the numbers of k is equal to the numbers of k plus 1 decrement k. So this is making sure that we don't have any duplicates in our array. Meaning, for example, if we want to increment j, and the next number that j is going to be pointing to is going to be equal to the previous number, we're going to keep on incrementing until we get to a new number because we don't want any duplicates in our result. And same thing for k. Now let's zoom out. This is all of our code. As you can see, let's run it and see if we're going to pass our tests. Yep, as you can see, all three of them are passed, like so. Now let's submit it. Moment of truth. Let's see if we're going to pass it. Yep, accepted, and we're beating 56% of all of the other submissions. That's awesome. Thanks for watching, and don't forget to like and subscribe. Keep on coding!